Alright, so in this video, we're just going to go over how to make a simple first-person controller in Unity. It's not going to be anything, too crazy. It's just going to be really simple, really easy. So first thing we're going to do, we're just going to create a plane, go there. Just so we have somewhere to put our player, we'll reset the transform on it. And then we'll create a new object, create a capsule for our player. Reset the transform on that, move them up a little bit. And you can rename it to player because this will be our actual player object. And then we'll go down to the bottom here, click add component, Rigidbody. You just search it up in the search, Rigidbody. And then we're going to set the interpolate value to interpolate that. And then we will take the camera that we have here, drag it under the player. And then you could just position this to wherever you want. So I'm just going to reset the transform on the camera. Drag it up a little bit, it doesn't really matter where you put it, as long as it's, on the player. Is we're just going to go into the Rigidbody here, go to constraints, we'll freeze the rotation on all of the axes, and then we are going to create the controller script. So this will just be, you could just call this player controller, right there. And then after it loads, we can go ahead and drag it onto the player object that we've created, open it up. We'll just create some variables. So this will be for our mouse movements. We'll create, if I can type, private float y and x for our mouse. We'll create a rigid body so that we can move the player. Give it a name, rb. We'll just name it rb. And then we'll create a bool to know if the player is grounded. Then we'll set the walk speed and sensitivity of the mouse. It doesn't really matter what you set these, we can always change it in the inspector layer. And then in the start, we're going to make the cursor lock state to lock the cursor so that we aren't, clicking off the game or whatever. And it looks good. And we'll set our rigid body variable so that it doesn't get broken. We'll go get component on that. So that way we have our rigid body set up, and then we will go into our update and create a simple look function. So we'll just go look and update. We'll go below that, go void look, so that this gets called every single frame. So X will be our X mouse movement. So minus equals, we have to subtract the mouse movement because it is like inverted on my mouse. So go GetAxisRaw, mouse Y, then we'll multiply that by sensitivity. And then so that our player doesn't look backwards and break his neck, we'll clamp the value so that they can only look up a certain amount and look down a certain amount. So we'll clamp it by -90 and 90. For our Y value, we'll add the mouse inputs. And then to apply this, we're just going to go Camera.main.transform.localPosition equals quaternion dot Euler. And rotations are usually dealt with in quaternions. That's just how Unity handles that. So we'll modify by the X and Y values, and then we don't want to modify the Z value. So that's all we need to do to look around. So if we go into Unity real quick, it should load, and if we click play, we should be able to look around. Yep, looks good, looking good. Alright, now for the movement part, we'll make this into a fixed update, because fixed updates, update and fixed update are different. So for it to be more smooth and consistent, we just want to put the movement into fixed update. So we'll make movement function, go down, go void movement, create that. And then in here, we're going to get the vector 2 axis, which is just the left and right, like A, D, W, and S. So we'll get that whenever you click that. We new vector 2 Input.GetAxis vertical. So that'll be our W and S and stuff. And then we'll go get the horizontal, which is A and D, so left and right. And then in this whole function, we'll go ahead and do .normalized. Because if you don't do this, whenever the player tries to walk diagonally, in a lot of games, they'll walk faster than they're supposed to. So that just makes sure that they walk the same speed all the time. And then we want to make sure that the player is always moving forward. So we'll go ahead, new vector 3. This is just whenever we apply the forces, just we'll get transform.right.t, 0. Then we'll get the... So this is basically just where we're looking. So it's going to be forward, you know, relative to the player. So that'll be forward, and then we want to get to our move direction from this, which has a lot of complicated math. So this will just be the forward variable that we just created times x-axis plus Camera.main.transform.right. That's z. Never mind, not that z. And then we'll go times axis.y plus vector 3.up times Rigidbody.velocity.y. And then we'll just set the velocity of our rigid body to that. So rb.velocity equals our move direction. And that should give us some movement. We'll see if I mess it up. Alright, yeah. So we can move around, look around and stuff. So to make our player jump, we're going to go into here and we're going to go into update. We're going to set the grounded variable to Physics.Raycast. So this is going to check under us and just check if we have, you know, something under us. Then we'll go to transform.position. So our current position, vector 3 dot, okay, if I can do it, vector 3 dot down, Camera.main.transform.localPosition.y, and then we'll just add this by 0.1, just so that it's just casting a raycast down below us, and we just want to add that little 0.1 so that it's checking below our capsule and not just like at our capsule, basically. Okay, and then we'll create a new if statement. We'll go Input.GetKey, and we'll go KeyCode.Space, so whenever the space bar is pressed. And if we are grounded, so if we're on the ground, we are going to set the velocity of our rigid body to a new vector 3, which will just be our other velocity, so rb.velocity.x, and then we're going to update the y, so we want us to go up, so that'll be 5. Just want this to be as it was. Yeah, that works. So we can run, jump around, do whatever. Looks pretty good. So yeah, that's it. Thanks for watching.